Hey guys, let's do the highlights of the first semester of geometry in 3 minutes. We start by getting points, the segment, rays, lines. We can have intersecting lines or parallel lines. Make it a coordinate grid, an XY coordinate to the endpoints, and we can use formulas to find the length, the midpoint, or the slope of the segment. And once we know lengths, we can find perimeter and area of all different kinds of shapes. Next, we can start focusing on angles. An individual angle can be acute, right, obtuse, or straight. The sum of the interior angles of a triangle always sums to 180 degrees. And we can categorize triangles based on these angles. We call it a right triangle if there's one right angle, an obtuse triangle if there's one obtuse angle, and an acute triangle if all three angles are acute. We can also categorize triangles based on the lengths of their sides. Scalene if all the sides are different, isosceles if at least two of the sides are the same, and equilateral if we know all three are the same. We can take a break from triangles for a second, but don't worry, we're going to come back. Right now, let's look at parallel lines. Let's toss a line through them. Let's call this the transversal. This makes a whole bunch of angles, and we can name and study these angles. We have corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. Some of these are congruent to each other, and some of these add up to 180 degrees, or in other words, supplementary. We can also look at perpendicular lines, which form right angles with their intersecting line. And we can observe fun things like the fact that two lines perpendicular to the same line will be parallel to each other. And if we bring back the coordinate plane, we can give equations to our lines, and we notice that parallel lines will have the same slope, and perpendicular lines have negative reciprocal slopes. Next, we can start doing things called transformations. We can translate, reflect, or rotate, and after we do these things, our figures will still be congruent. And after a dilation, which makes it larger and smaller, figures will no longer be congruent, but they will still be similar. Let's look deeper into congruence. We say that two figures are congruent if every angle and every side has a corresponding congruent part in the other figure. And if we focus on triangles, we don't need to know everything. If we know that three sides of a triangle are congruent to three sides of another triangle, that's enough for us to know the two triangles are congruent, and we call this SSS. Or if we have the same thing for two sides and the angle between them, we call that SAS. Or if we have two angles and the side between them, that'd be ASA, or two angles and a side not between them, that would be AAS. If it's a right triangle, we call it HL for hypotenuse leg. And once we know two triangles are congruent, we immediately know that the remaining corresponding parts are congruent. We call this CPCTC, or corresponding parts of congruent triangles are congruent. And if we look into triangles more, we can cut them 4 different ways: perpendicular bisector, angle bisector, median, altitude. They will all meet at circumcenter, incenter, centroid, and orthocenter. And each point has unique properties. Another way to cut a triangle is by connecting the midpoints of two sides. We call this the midsegment. And the midsegment is always parallel to the last side and half its length. And there's even more about triangles. For every single triangle, the sum of the two smaller sides must be greater than the third. If not, they can't form a triangle. They won't reach each other. And the largest side is always opposite the largest angle, and the smallest side is always opposite the smallest angle. And those are some of the highlights of first semester geometry. How exciting.